Yeah. So, as asked by you, today's session will be only about whatever I feel would be important for the exam. So, we will be discussing few important questions and their concepts. So, I believe through them you will be able to fetch very good marks in the examination. Uh, so, this is going to be the eighth and the final weekly live session of this NPTEL course of river engineering under the NPTEL and SWAM scheme. This course has been tutored by Professor Subhashish Datta from the Department of Civil Engineering at IIT Guwahati. And I happen to be Abhishek Chakraborty, a PhD student under the Prime Minister's Research Fellowship Scheme at the Interdisciplinary Center for Water Research in IISc Bangalore. Yeah, I mean, just going back to, I mean, what I talk about in the initial phases of every lecture, we are downloading everything on our YouTube channel. The link is given here, and we are also uploading everything on this Google Drive folder. So please go through them. We will try to upload them as early as possible after the class. So I will just check whether I have actually started recording it. Yeah, I have. So we will solve some questions which I believe would be very important for the course. Let's start it then. Someone also asked me to solve a question related to the Navier-Stokes equation. I will be doing that too in this session. So let's start it up firstly. Yeah, some of the formulations are very easy. If you want to know critical energy, so it is 1.25 times of yeah, we will go back to it after a bit, but yeah, let me just solve a few questions. So let us take the first question. There is a trapezoidal channel. The bed width is B, and the side slopes would be something h. Let us suppose the bed width happens to be 4 meter. The side slope, let us suppose, is 1 point. Side slope happens to be 1.5 horizontal is to 1 vertical. So this is 1.5 and this is 1. So it would carry some certain discharge uh, out of the plane of the slide which you are observing it, right? So the question would be like, let us suppose the critical depth of the flow is estimated as 1.70 meter for this trapezoidal channel. Then, what would the discharge in the channel? What would the discharge at the critical depth? That would be one question, one type of question for trapezoidal sections. Then, so how would you solve it? So, for solving the trapezoidal channel-based sections, we firstly always need to find out what would be the, or any question related to open channels. We need to know or very clear with the area and the top width of the section, right? So, area would be very easily known if this is yc in our case, because we want the discharge at yc, y equal to yc. Then this would be what? This is 1.5. So this would be something. So, so, so you can just take out this 1, 1.5. So 1 by 1.5 would be what? 1 would be yc divided by x. We want to know x. So what would be x here? I mean this x. What would be this x? So x would be yc times 1.5. So this would be 1.5 times yc. This would also be 1.5 times yc. This we know very well is width of the channel b. The bottom width is bottom width and I mean uh, bottom width. So what would be the area? So the usual equation for the area of a trapezium would be b plus myc times yc for a depth of yc of the channel. So what would it be? B, let us suppose, was given as 4 meters. So 4 plus m is given as, so if it is 1 vertical is to m horizontal, then this formula you can straight away apply for trapezoidal section, or you can derive it just like I did in the initial classes. So it would be 4 plus uh, m is 1.5 times yc is given as 1.70 meters, okay, uh, times yc again 1.70 meters. So this area of the channel at the critical depth would be what? 11.135 square meters. The top width is what? Top width we know is b plus 2 times x. So b plus 2 myc also we can write in this notation. If it is 1 vertical is to m horizontal. So it is 4 plus 2 into 1.5 into 1.7. So this would come out to be 9.10 meters. Take another slide. I believe today's session would be a long one. So that I would try to finish everything possible. So how do you solve the critical depth and discharge formulation for such a complex open channel? We have already a set of beautiful equations for a rectangular channel, for a triangular channel, but we don't have anything like that for a trapezoidal channel. So for that, let's go back to the most common equation: q square g equal to ac cube by tc, where c subscript is basically relevant to the critical depth. So we already found out ac, we already found out tc, we already know what is g. So q would be nothing but square root of ac cube g by tc. So we just substitute all the values here to get a final value of 38.579 meter cube per second as the discharge. So, I mean, if someone asks you about the discharge at a critical depth, how would you find it for a trapezoidal section? You would just go back to the first principles. First principles means the most generalized formula. So, this is the most generalized formula. This is basically applicable for every open channel. This is going to apply even for, let us say, uh, what do we say, a rectangular or a triangular open channel. Although they have very beautiful equations to find out the critical energy, but you can even derive it from this expression. Okay. Now the second part of the question was the second part of the same question could be something like if this discharge, if we observe this discharge at depth y equal to 2.50 meters in a reach, then find out the fr. Then what would be the fr? I mean, fr means the Froude number. So how would you find out? So y is given here, but y is not equal to yc, so you cannot apply this formulation here for y not equal to yc. Okay, so you have to go back again to the first principles. I mean, you have to find out the area, you have to find out the top width. So area for this trapezoidal section would be b plus my times y, and that is 4. 4 was the width, plus 1.5 was the horizontal based value, times y is 2.50 times 2.50 again. So you get 19.375 meters square as the area for it, for this depth. Similarly, you need to find out the top width. Top width would be b plus 2 my. You can either memorize these two equations for the trapezoidal channel, or I would rather say that you can derive it. I mean, it would barely take you 30 seconds to derive it. Okay, so this would be 4 plus 2 into 1.5 into y is 2.5, comes out to be 11.5 meters. Next slide. So the hydraulic mean depth is a by t. We know it very well. So a by t is 19.375 by 11.50 equal to 1.685 meter. Okay. We know, because we are finally trying to find out the Froude's number. Froude's number value is square root of gd. Okay, So G we know already. D now we know from this formulation. We need to find out V also for Froude's number. So V would be discharge by the area. Discharge is already given is as 38.579 meter cube per second, and area is 19.375. So it would be 1.991 meter per second. Just put the values to find out the Froude's number. 1.991 by square root of 9.81 into D is 1.685. So the Froude number would come out to be 0.490. So this is Froude number is less than 1. So this is supercritical. So they may either ask you in the exam to calculate the value, the absolute value of the Froude number, or they may finally ask you whether the flow is subcritical or supercritical. So for that also you need to find out the value of the Froude number. You cannot straight away say. So 0.49, it is 4.490, it is 0 less than 1. So it is, sorry, not supercritical, what am I writing? It is a subcritical flow. Any question from this? Because I wanted to discuss this first of all because this is the most generalized equation from this from the earlier parts of our lectures on remote engineering. Any question? Please quickly respond to me today because I plan to discuss a lot of stuff. Okay, so is any question related to this? Yes, sorry.
No questions, sir. No.
Okay, okay. So I will keep asking this today because uh,
Yeah, yeah.
one question like this will certainly be in the exam without any doubt. It may either be
Oh,
on rectangular channel, but I believe it will be on a trapezoidal channel because they are
okay.
the most
Okay.
complex ones. I mean,
Sir,
relatively.
actually, one doubt regarding exam. So, all questions are MCQ or some may be fill in the
No, some are
blanks. That you are telling
NAT,
something.
numerical answer type. Some are
Okay.
Some are
Okay.
MCQs, and some are just like GATE. I mean, you might have given GATE sometime.
Yeah,
So
yeah.
I mean, they may ask you to solve, let us say, 3 plus 4, and then write you to ask the answer in answer up to one decimal. So you would write the answer as 7.0. No, okay,
Okay.
just like GATE, either
Okay.
MCQ or NAT,
So, how
numerical
many
answer type.
questions will be there, sir? 100 or something like that? Number of questions.
That I don't know. That I don't know.
Okay.
But
Okay. Okay.
okay, that I don't know at all.
Okay. Okay.
Anyways, I mean, we will continue then, and I will
Okay.
keep asking you. I mean, so
Yeah.
that
Yeah.
everything is solved because we are not going to meet again. So it's good for me if
Yes.
you, I mean, reply very soon. Okay.
Yeah. Yeah. Yeah.
Next kind of question may be about and maybe basically from the send variance equation kind of questions. Send variant equation. So we already solved one sort of question from the critical flow. These are the questions from critical flow. And this, I believe, is the most complex question from that part. Critical flow, critical discharge. This is the question related to that. Then we will solve one question from Saint-Venant's equation. So Saint-Venant's equation we know very well is basically valid for unsteady open channel flow. It gives us the principle of conservation of mass as well as that of the momentum. Okay. So the question may be like the flow velocity can be given as 10x square. I'm just taking this question from one of the assignments actually. Okay. And the flow depth h, flow velocity can be, let us suppose, 5x square t square equal to the flow depth. Okay. The top width t equal to the top width can be given as 3x cube, and area of the flow can be 25x square area of flow. Okay. Then find out the lateral flow at, they will since you have to report a number, so x equal to 1 meter and t equal to 5 seconds. What is the lateral flow? So for this, I mean, these questions are very simple actually. You just need to memorize what the Saint-Venant's equation is there. Saint-Venant's equation is for lateral flow conditions. So for the unsteady open channel flow, the Sentiment equation would be del u del h by del x, where h is the flow. I mean, I've already described what the notations mean. Plus hd del u by del x plus del h by del t equal to ql by t, where QL is basically the lateral flow. So how would you solve it? You know, so HD is the hydraulic mean weight, which we know is A by T. A by T, A is 25x square, T is 3x cube.
Sir,
So
is it here dou H by dou T or dou U by dou T? Please,
del H by del T. Which one? Which
del
one?
H by del T only?
The last term, right? This term, right?
Yeah,
Last term
last.
of the LHS.
Yeah, yeah.
Yeah, this is del H by del T.
Del H by del T only. So
Yes, yes,
please,
yes.
I believe that may be dou U by dou T. So
This is del H by del T. Check the sentiment. I think I solved the same equation in the last class also. I'm solving it again just because I think
yeah.
that this is one of the most important
Okay.
questions which will come in the exam. This is del H by del T. What happened? Please go on. Please ask me.
Okay, sir. Carry on. Yeah.
Okay. So this would be 25 by 3x. Then del H by del x term is there in the sentiment equation. So del by del x of 5x square t square, which is 10x t square. Then del u by del x term, which is del by del x of 10x square, which is 20x. Then del h by del t, which is del by del t of the last term, 5x square t square, which is 10x square t. Just put the values in that equation. You will straight away get the answer, by the way. So we are putting the values 10x square times 10x t square. It is one from one of the assignments actually. 25 by 3x times 20x plus 10x square t is ql by t. So that is 3x cube. So we just put the values x equal to 1 meters and t equal to 5 seconds. So after substituting, we'll get QL directly as 8150 meter cube per second. So these questions are basically very easy if you know how to use the Saint Bernard's equation. Just use it and you will get the final formulation from that. Let's move to another question. Now we are moving to questions related to Manning's equation. Manning's equation and Strickler formula. Very important part again. Very important. All the three questions parts which I have covered so far are very important. May come very easily. So the question would be like median size of grain particle, median size we know is D50, is given as 0.25 mm. The channel is trapezoidal. The channel is trapezoidal. Bed width means the bottom width of the trapezoidal section is 2.5 meters. Side slope is 1.5 horizontal is to 1 vertical, just similar to what we did earlier, the side slope. Then longitudinal slope is longitudinal slope equal to 0.00045. So if the canal carries a discharge of 1 meter cube per second at depth of zero point 0.6 meters, then find Manning's coefficient due to grains equal to ns. So this will basically come from the Strickler's formula, and this may be asked what is the Manning's equation, and then the shear stress due to grain roughness. So that we represent as tau dash. What is that exactly? Okay, so let's write the prominent formula for this. So Manning's equation, Manning's coefficient due to grains would be the mean diameter power 1 by 6 by 21.1. It's a very prominently used equation. So D50 you don't know, and this is required for the first part, and for the second part you need to know the shear stress due to grain roughness, that is ns by n is the Manning's roughness coefficient times gamma rs. Gamma you know is rho g. So how would you find out? I mean these two equations you have to use somehow, and they have given that it is a trapezoidal section. So what would you do? You would again do the same thing. You would find out the area of the trapezoidal section. Area is by plus zy square. So that would be 2.5 into zero point 0.6 plus z is 1 is to z. So 1.5 into 0.6 square equal to 2.04 square meters. So area of the trapezoidal section is found out. What is the wetted perimeter? Because here we need to find out the hydraulic radius, and hydraulic radius is r equal to a by p. So we need to find out the wetted perimeter here. This is not a question from the critical flow. This is a question from the Manning's roughness part, which requires us to find out the hydraulic radius. Okay, so the perimeter of a trapezoidal section can be represented as b plus 2y square root of 1 plus z square. So it is 2.5 plus 2 times 0.6 square root of 1 plus 1.5 square. It is 4.66 meters. So from this you need to find out r, the hydraulic uh, radius. R is a by p. So it will come out to be from 2 point, so it means 2.04 divided by 4.66. It will come out to be 0.44 meters. Now you have to find out ns finally. Ns means what? Ns means the Manning's coefficient due to grains, or we are using the Strickler's formula D50 1 by 6 by 21.1, which comes out to be straight away 0.012. Now you have to find out the Q. We need to find out the discharge also at 1 meters per second. So let's find it out. Q is equal to 1 by n. Just use the Manning's formula, a to the power r 2 by 3, s to the power half. Okay. So n, we have to find out n somehow. N is equal to 1 by q for the next part of the equation, because we need to find out what n is. 1 by q, just take that here, into a r to the power 2 by 3 s to the power half. S is the longitudinal slope. So putting the values, the n or the Manning's roughness coefficient would come out to be 0.025. So the shear stress due to Manning's grain roughness would be ns by n to the power 3 by 2 gamma rs. So ns is given as 0.012 from the last problem. Yeah, from the Strickler's equation we found it out as 0.012 by n, and we just found out as 0.025 power 3 by 2. Gamma is rho times g, so 9.81 into 10 power 3 into r. R was 0.44 times the longitudinal slope 0.00045. It will come as approximately 0.645 pascals. So this question basically constitutes of two parts. First of all, we need to find out what this grain coefficient is. Okay, so grain coefficient is the first part. I mean, you need to find it out, and in the next part you need to find out what is the shear stress due to the grain coefficient. So it's a straight away question, but you need to be very solid with the area and the perimeter of a trapezoidal section. If you know that, I think these questions should not be tough. But I believe you should be. I mean, these two equations you should be memorizing. These are very important for the exam. Perimeter, if you are finding it tough to, I mean, memorize, you can even derive in the exam. Or shall I derive it now? Or is everything okay? Please tell me. Everything okay with the question, or anything else you
Yeah,
want to
yeah, okay,
discuss?
sir. Okay,
Okay,
okay.
okay. So by this time we have solved the third kind of question, which is on trapezoidal section again, but with Manning's one. Now the fourth kind of question will be on the scout depth. So I mean these questions I have taken just from the very prominent equations from I mean prominent problems from the assignments. Yeah. So the fourth is. Uh, the question states that there is a broad crested weir and it is built around a 40-meter wide river. So the width of the river is 40 meters. The drop height is 2.5 meters. So drop height is 2.5 meters. Drop height is 2.5 meters. Face angle of the structure, the face angle of the structure is 40 degrees. The face angle is 40 degree equal to the face angle. The scout slope is approximately the scout slope is approximately 1 vertical times 2 horizontal in non-cohesive material with D50 median dia as 2.5 mm. Estimate the scout depth. What is the scout depth? When river discharges at river discharge of 160 meter cube per second. What is the scout depth then? Okay. So there is a very common formula which is you have to remember this somehow. So the scout depth equation is delta z equal to 1.8 times sine phi by sine phi j plus phi power 0.8 q to the power 0.6. Uh, q is the discharge per unit width. V1 is the approach velocity sine phi j by g minus 1 times g power 0.8 ds power 0.4 minus dp. Okay. So the question is very straightforward. You just need, I mean, the question is basically checking whether you memorize this equation or not. It's a bit tough, I understand that, but that's the nature of this proof. So discharge per unit width we have to find, because we need to find out indirectly the velocity also. So for that we need to find out the discharge per unit width. First step, that is q by b. So q was given as 160 meter cube per second. P, the width of the channel is 40, so it will be 4 meter square per second. dp is basically the drop height. It is 2.5 meters. ds is the median dia. It is 0.0025 meter. Theta j is basically tan inverse 1 by 2, I mean from the scout slope. So it is what is tan inverse, the vertical times horizontal part, what vertical by horizontal part. So this would be 26 degree approx. Phi is given as 40 degree, that is the face angle. Face angle is given as 40 degree. So the first step in this in such questions is number one, finding out the HC, that is the critical depth, q square by g to the power 1 by 3. Yeah, we have this very good equation only for the rectangular section, and that too requires the discharge per unit width. So this would come out to be 1.18 meters after putting the values. The next part is V1. V1 will come out to be q by hc, small q, that is discharge per unit width by the critical depth. that is 3.39 meter per second, and finally you need to find out delta z, the scout depth, that is 1.8. Just putting the values: sine 40 degree by sine 26 plus 40 degree power 0.8 times 4 to the power 0.6 into, we solved a very similar question in one of the assignments actually. Sine 26, I think assignment 7 or 8. 2.65 minus 1. If the what do we say, the specific gravity is not even given in the question, just assume it as 2.65. 9.81, but it will be most probably given. Zero point 0.8 into 0.0025, that is ds power 0.4 minus 2.5, the answer will come out to be nearly 3 meters. So the funda of this question was that you need to apply this equation somehow. You need to memorize this, and then everything will be easy. And some of the values will not be directly given, so you need to find out for this equation small q, v1, and you also need to find out what this phi j is. So phi j is basically tan inverse vertical by horizontal scour angle, face angle. Okay, so apart from that, it is a very straightforward question, but you need to be memorizing this equation. This is very important. So scout depth part is done. Let's move into the next part. Uh, let's solve. I mean, we have so far solved three most important and tedious questions from our analysis. Now let's solve something else. Let's just solve another type of centre-variance equations, centre-variant equation problem. The one which I showed earlier was the one to find out the lateral discharge. That was one kind of Sentiment equation problem. We have to find out another one. I mean, we are solving another kind of Sentiment equation problem here. Okay, so uh, in that kind of problem, the flow velocity will be given as a function of position and time. So let us suppose it is 1.5, 2.5, 2x cube plus 1.5 t square plus 3. Then the flow depth is 5x cube t square, and the bed slope is 3x square plus 2. So they want to find out the friction slope. What is the friction slope? This is the bed slope. What is the friction slope? So that may be another type of Sandverance equation. The first one which we solved was basically an application of the conservation of mass part of the Sandverance equation. This question actually requires you to find out the bed friction slope. So basically, indirectly, the examiner wants to know whether you remember the momentum part of the Sandverance equation or not. So from the Sandverance equation, the formula is SF equal to S naught minus del H by del X minus u by g del u by del x minus 1 by g del u by del t. So del h by del x, let us solve it here itself. Del h by del x is 15 x square t square. 3 will go there, so it will be 15 x square t square. Del u by del x is 6x square. Del u by del t is 3t, and S naught is already provided here. Just put the values here. So it is 3x square plus 2 minus 15x square t square minus 2x cube plus 1.5 t square plus 3 by 10. G is supposed to be taken as 10 into 6x square and minus 1 by 10. Take g as 10. Let us suppose the g, it would be given in the equation, question. So 1 by 10 times 3t. So you have to find out the friction slope in the question at x equal to 100 meters and t equal to 1 hour. So what would that be? Just put the values. So just put the values here. So x equal to 100 meters and t is 1 hour. But we need to, make the units consistent. So the unit has to be put not in hour but in seconds. So 1 hour has 60 by 60, that is 3600 seconds. So SF after solving it will come out to be minus 2.07 times 10 to the power 12. So that would be one of the options in the MCQs. You will get it out, get it like this. Just to confuse you, they may also give you an option as plus 2.07 into 10 to the power 12. You need to take the minus 2.07 to 10 to the power 12. They will try to confuse you. So this part is also done. This is the part on the momentum part of the Saint-Bernard's equation. Let's move into the next part. Okay, so this is the next part is on the Navier-Stokes equation, which uh, which you Nagendra actually asked me to discuss in today's class. So there is a steady two-dimensional incompressible velocity field, which is basically the assumption. Requirement for Navier-Stokes equation. Navier-Stokes is basically quite generalized, and it is the most generalized equation for fluid flow. So they're already stating the parts also. So it's steady, two-dimensional, and incompressible velocity field with u as means the x direction flow velocity, ax plus b, v as minus ay plus cx, where a, b, and c are constants. Okay, so calculate the pressure. Find pressure as a function of x and y. This would be the question. Pressure. You need to find out the pressure as a function of x and y. Okay. So first assumption is that we have to. We have been told nothing about the body force part. So just assume. In such question, that will not be given directly, but you have to assume that the gravity does not act in either. Just a second. Someone is calling me. Hello. Good evening, sir. Sir, actually, I'm currently taking this NPTEL session. I will call you back in a while. Hello, I'm back. I'm very sorry for that. Yeah. So gravity does not act in either the x or y dimension. That is the first assumption you have to take already. So for such questions, firstly you need to check whether this is actual fluid flow or not. You may check that or you may not even check that, but for the purpose of this live session, let us do it. So del u by del x plus del v by del y should be 0. Is it 0 here? So del u by del x is a and del u by del y is minus a. Yeah, so it is 0. So it is actual flow. There is conservation of mass at least. So that we don't need to worry about. Need a few more equations. Okay, now you just solve the Saint-Venant's equation. So the Saint-Venant's equation is for the y direction component is del v by del x plus v del v by del y equal to minus del p by del y plus rho g y, which we have already assumed to be 0 actually, plus mu del 2v by del x square plus del 2v by del y square. Okay, so since it's a steady flow, first of all, given in the problem, it can be assumed as 0 because it is steady. The question is already giving you this information. It is a steady flow. Gy is given. We have to assume. Since Gy, is not given, so just assume that it is zero. I mean, body force is not acting either in the x direction or the y direction. Just assume it. Okay. So after simplifying it, you will get this term as del p by del y equal to uh, rho minus acx minus bc minus a square y plus acx. This would again be rho minus bc minus a square y. So this is the del p by del y component. So which we found out by solving the y direction component of the Sandberg's equation. So similarly solve the x direction component also. So from that x direction component, you will get x direction component of the Sandberg's equation. So what do we need to do that? You just replace all v with u. That's the only thing you need to do. I mean, this v is to be replaced by u, this v is to be replaced by u, this v is to be replaced by u, and these two v's are to be replaced by u. These are anyway zero because we are assuming that it is inviscid flow. So this is again zero. So you are left with only these two components. Okay. So del p by, similarly another expression for del p by del x will be coming, and it is rho minus ab minus a square x. So we need to find out p as a function of x comma y. How do you find it out? So you have to integrate it once. Let's do it. Let's do it in the mix, right? So integrate just one of them. Integrate just one of them. One of those partial differential equations once. So let me say that we are integrating it, partially integrating it, minus bcy minus a square x square by 2. So if we are integrating that del p by del y term, so what would be the constant? The constant would be a function of x alone. Okay. The next phase is that we again differentiate it with respect to x and then equate it with the del p by del x expression. So this is the funda of these equations. So this would be uh, let us suppose g prime x, which will come as rho minus ab minus a square x from the previous equation. So what do we get? G dash x is something like gx is just integrated once again. You will get minus abx minus a square x square by 2 plus c1. So that you put into this expression. So p of x comma y is rho minus a square x square by 2 minus a square y square by 2 minus abx minus bcy plus C1. So that would be the final answer of the pressure representative. So the funda is that, I mean, we'll just quickly go through the funda. Any question based on Navier-Stokes equation, you need to first of all find out, be very sure about what Navier-Stokes equation is. And then they will give you some assumption in the problem that half of the expressions will anyways be zero. So this mu term will be zero in our analysis in our when we solve the problem. The body force term can be taken as zero. So the first part is to take the y component Sandberg's equation and then take del p by del y to one side, and then we can equate del p by del y to something from the help of the quotient. Then you solve the same Sandberg's equation but for the x component. So from that you will get another equation, del p by del x is equal to something, and then integrate one of the equations once. So if you integrate the equation related to del p by del y, then the constant will be what? The constant will be a function of x, and then you equate that term. You again derivate that term with respect to x and equate it with the del p by del x expression. Using that, you will get the gx term already. Okay, so this is the way you solve this Sandberg's equation based. Sorry, Navier-Stokes equation based problems. Is it done? Is it easy to understand? Did you understand this? I hope you understood this, because this I think will come in the exam. I mean, if they have to frame any question from the Navier-Stokes equation, then this has to be the one. You understood the funda? Hello. Okay, I take it as a yes. I hope you understood this. The funda is very simple. You just memorize the Saint-Bernard's equation. Okay, then you try to bring this del p by del y term from the y direction Saint-Bernard's equation on one side. So del p by del y would be something. Similarly, from the x direction, Navier-Stokes equation, you bring the del p by del x term on one side, and that would be something. Then just integrate this del p by del y term. So the constant of the integration would be a function of x in that case. Then again derivate that expression, differentiate that expression, and equate it with the del p by del x. You will finally get the constant of integration from that was gx in our term. Okay, so this is how we solve another set of question. Now the last major question would be prominently from the Colorado state equation formula. So Colorado, I will just give the equation here. The Pier scout depth from the CSU expression, from the CSU equation, the Colorado State University equation would look like delta Z. If they are asking Pier scout depth, then you have to use this CSU. So 2 H1 K1 K2, which are the constants, A by H1 power 0.65 into the approach Froude number FR1 power 0.43. Okay, so the approach Froude number is to be found out as V1 by square root of GH1, whatever depth is given. So from that you will find out FR1 for this expression. H1 is the depth of the flow. So if it is a circular pier, then K1 would be 1. Now we have to find out the pier length by width ratio, which is L by A, which will come out as something in the equation. You have to find it out. Okay, if the pier aligned with the flow, if it is aligned with the flow, so the orientation angle theta would be 0 degree. So K2 corresponding to 0 degree would be 1.0. This will be either given in the question or just you can assume K1 and K2 to be straight away 0. Okay. So put the values in this expression. You know everything by now. So you would be provided with the pier length. You would be provided with the pier width. Everything is given already. You just put it there and you will get some value. So this is the third kind of prominent problem from the pier scout depth or scout depth. The first one was from riprap, which from for which we utilize that large expression related to sine phi and sine theta j. Okay, this one is from the Pierce scout depth, and this for this you have to use the Colorado state equation formula. Now let's move to something else. I will give you some important formula now. What is the dimensionless particle? If they ask you the dimensionless particle diameter d star, so that is basically the particle diameter times g minus 1 g by kinematic viscosity coefficient square power 1 by 3. You saw, you just put the values, which will be given straight away in the questions, so you will get it there. Nu is the kinematic viscosity coefficient. What would be the settling velocity? So it would be of sediment particles, it would be 8 nu, the kinematic viscosity coefficient, times the particle size dia, 1 plus d star q by 72. It's an empirical formula. Okay, just put the values, we will get another part. So these are the questions related to the dimensionless particle dia and the sediment velocity. Okay, so I think I'm done with the major problems already. We discussed seven different kind of problems which may be asked in the 5 mark questions. I mean the questions which will carry the most marks in the exam. Now let's solve some of the uh, easier questions. I mean the questions which would take you 1 or 2 line only. Okay, I will give you the formula. You can straight away find out. So what is wave celerity? If the question wants you to find out what is wave celerity, so that is the denominator of the Froude's expression. That is square root of GD for. I mean, if they are asking you what is the wave celerity, so for rectangular channel it is square root of GY. So wave celerity can be told as directly proportional to square root of Y. This is done. This is one of the questions in the assignments also. Then they may ask you the critical depth for rectangular channel, critical depth of rectangular channel or the critical energy. For rectangular channel, it is 1.5 times YC. For triangular channel, it is 1.25 times YC. So if you know what is the critical depth, you can find out the critical energy. And if you don't remember anything, then please go back to the original equation which I started this class with. Yeah, if you don't remember anything, you can easily derive it from this expression. Okay, then what else? What else I need to discuss? This chapter. Okay. Yeah. So one of the question may be, so one kind of question will be, I mean the rate of change of momentum from Newton's law. So Fx will be nothing but rho AU. I mean times U2 minus U1. I mean the net force in the x direction. If someone wants you to find out the net force in the y direction, it would be V2 minus V1. These values will be given. You just straight away find it out. Then that is one sort of question. Then okay. So one another important type of formula would be stream power per unit width of so per unit of stream length. It would be equal to gamma 1 equal to rho g q s, where q is the discharge and s is the longitudinal slope. So just putting it, you will get value in watts per meter finally. Okay, what else? Then there were questions related to I mean prototype. Yeah, anything to ask? I can hear noise.
Related to wave velocity, like
Yes, please go ahead.
some questions are there related to wave velocity.
You are not audible. I don't know what's wrong. In that case, you may type it in the chat box. Is there a chat box? Yeah, we do have a chat box. You may type it in the chat box if your, I mean, audio is a bit erroneous right now. Okay, Nagendra wrote that, sir, your voice is bit low. Am I audible?
Yes, sir. Yes, sir. You are
Okay,
audible.
okay. Yeah, I will come to that also, Shamla. The wave velocity questions. I will come to that also.
So in that one, stream power per unit mass per unit. There are
Per
three
unit
equations.
length. Yeah. You have to just use that equation. Some of the equations
Yeah,
you have
yeah.
to
Applying
memorize.
the equations.
Exactly, exactly. I will come back to everything. Okay, I will discuss each and every important question,
Yeah, yeah.
and I'm pretty sure that many questions will be assignments from the assignments will be repeated in the exam. I am pretty sure
Okay.
they may change numbers, but
Um,
more or less they will be repeating it. That is what I believe.
Sorry, on abutments cover depth also please give the formula. So like number of formulas are there.
Okay, okay, okay. Just give me some time. I will.
Yeah.
I'm just finishing it up. I'm just noticing what else to discuss. I mean, what are most important parts. Okay, so this is done. Yeah. Now some sort of questions from the sheet. Okay, we are coming to that sort of question now. Okay. Uh, so some questions from the meandering. If the Thalweg width, Thalweg length is given as 6 kilometer. Thalweg means the point of the deepest part of the channel. Okay, 6 kilometer, and air distance is 1 kilometer. What is the sinuosity? Sinuosity is 6 kilometer by 1 kilometer in that case. I mean Thalweg length by the air distance. I mean basically sinuosity means the curved length divided by the straight length of two different river reaches. So it would be 6 in our case. What else? Then they may ask, is this river a meandering river? I mean they may ask something like that. So if sinuosity greater than 1, then it is a meandering river. Then they may ask you to find out the Shields number for bed particles. Shields number, the formula is uh, Hs by G minus 1 ds, where ds is the depth of the, sorry, the dia of the particle size, h is the depth of the flow, s is the longitudinal slope, g, capital G we know is the specific gravity. So from that you will find it out as something. What else? Yeah. So we are done by this. Now a question on riprap design. I mean, what would be the riprap design? Let's let's try to discuss that also. Riprap design. Okay, so if the riprap thickness is 45 centimeter, filter thickness equal to 25 centimeter. So let us. I mean, the question basically wants you to firstly take D50 of the filter as 5 mm for one case, D50 of the D50 of the base as 0.8 mm, then for another case D15 as of the filter as 4.8 mm, D15 of the base as 0.45 mm, and D85 of the base as 0.85 mm. So I mean, if these things are given, then the question will finally ask you, is the riprap design satisfactory or not? And if it is not satisfactory, then which parameter is actually making the data erroneous? I mean the design erroneous. So for riprap design, you need to find out D50 of filter by D50 of base. From this case, it is 5 by 0.8, which is 6.25. So it is less than 40 as per the specification. So this is okay. Again, the second criteria is 5 less than D15 filter by D15 base less which is here 10.66 should be less than 40. So 10.66 is between 5 and 40. So design is again okay according to this criteria. The third one required you to use D80 85. So the third one, this is the first criteria. This is the second criteria. The third criteria for stability of riprap is D15 filter by D85 base should be less than 5, but it is 5.6564, not equal to 5, so not okay. So the question will ask you that which among these parameters is making the riprap design unsatisfactory. You can say that D85 is actually making the riprap design unsatisfactory. So this would be another type of question. Let's move. Okay, now one question from the model and prototype. I already gave you many expressions about a model and prototype, but one expression which may be asked is from. Okay, so first of all, I gave you QP by QM equal to QR. The first expression is LR to the power 5 by 2. That is the first expression to. I mean, if, in case you want to find out uh, what the discharge would be for a. I mean, if you know it for a prototype, then what would the discharge be for a model? The time length, the time ratio is square root of LR. That is another equation. Discharge ratio is LR to the power 5 by 2. That we also know. And the third one, which I didn't give in the main class, was the hydropower ratio. So it is basically rho R LR to the power 7 by 2. So rho R is basically the ratio of the model to the prototype, the density ratio. So it is 1. So it is LR to the power 7 by 2 straight away. So this equation I actually didn't include in the weekly live session. So this is something new apart from these ones which are already discussed. So this you should also remember. This may be asked for the fraud similitude. Then yeah, let me ask to use a few more slides. Okay, so one type of question may be okay. So for another important formula is for only rectangular channels, the critical depth is basically this. You know this already by the way. Only for rectangular channel. This is only for rectangular channel. Only for rectangular channel. Okay. What else? Then they may ask you whether I mean they may give you some v bar. V bar would be something, let us suppose 10 x square I cap minus 10 y square j cap. They may give you the velocity field. They may also give you the density distribution 8xy. First of all, you need to check whether it satisfies continuity equation. So that is del u by del x plus del v by del y equal to 0. Is it 0? So let us check. So del u by del x is 20x, del v by del y is minus 20y. Okay, so it is basically a compressible flow. So for this, the equation will become del rho u by del x plus del rho v by del y equal to 0. So let's check what happens. So del by del x of rho u is 8xy. So that would be 80 x cube y plus del by del y of 8 times minus 80 uh, x y cube. So is it 0? Let's check. It is 80 times 3, so 240 x square y minus 240 x y square. Is it 0? No, it is not 0. So the continuity equation is not satisfied. They may ask this. I mean, they may give you a velocity field, they may give you a density field, and they may ask you whether the continuity equation is satisfied or not. So, since it is not equal to zero, so this means that the continuity equation is not satisfied and flow does not occur. Then some questions from the sieve analysis. CU, the coefficient of uniformity is D60 by D10. Coefficient of curvature is D30 square by D10 D60. These are basically questions from the earlier parts of our classes. So this you will do very well. Then what
CC
else?
may be D10 into D60, sir. CC form.
Oh, sorry. This is D60. Sorry. Okay, so this part comes from the very earlier part of this class. Then yeah, so one question, I mean, will be like this. There may be a spillway, so there may be a spillway like this. There will be some depth here, y1. There may be some depth on the other side, y2. Okay, so they will give you like these, let us suppose these are two alternate depths. So what would you do? Alternate depths means that the specific energy at y1 and 2 will be equal. So just equate the expressions. Y1 plus q square by 2g a1 square equal to y2 plus q square by 2g a2 square. Just put the values, you will get the values of q from it. So sorry, y, if they are asking y, they may give that y here is 2 times y1, y2 is 2 times y1, or they may ask you the value of q. So y or q, whatever you require, you can find by just solving this equation. So this equation is important. Then yeah, then one question from momentum correction factor. Momentum correction factor equal to beta equal to 1 by a v by v will be, the distribution will be given, times square by dA. So this is the momentum correction factor. So if it is a circular pipe, for circular pipe, let us suppose they are asking for circular pipe. So a will be 1 by 4 pi r square. The sorry, 1 by pi r square, the cross sectional area, times 1 minus r square by capital R square 2 pi r dr. So this I have actually solved very well. The this part's derivation is there in one of the earlier weekly live sessions. So questions related to momentum and kinetic energy correction factor may be given. So you can straight away find it out like that. Then what else? Then there may be question about the stability number. So that is eta naught equal to tau naught by tau c equal to tau naught by tau c, we know is g minus 1 rho g ds tau star c. So just put the values, you will get another stability number if they are asking questions related to stability number. Then rock riprap design, questions related to rock riprap design. What else is left? Two equations from here. Okay, so if they want to find out the shear stress applied on the particle, so it is gamma hs straight away for a particle. Then riprap size, if they are asking riprap size dia, so that is coming that will come out to be tau naught from this expression by eta tau star c gamma s minus gamma. So This basically comes from g minus 1 times d. The d is going on the left hand side. So just put the values, you will get another thing here, another set of values here. What else is there? Then there may be questions related to terminal fall velocity. Terminal fall velocity. So from that part, it is 4 by 3 g minus 1 times uh, g times d by coefficient of I mean the CD factor. What else? So this is also done now. This part is done now. Uh, what else is the most? Let me just check it.
Formula on abutments covered up, sir.
That that you will. I mean that you can check from the assignment. I'm just actually today discussing the most important questions.
Yeah.
Okay.
So this terminal fall velocity also other than CD, is there any formula? So there may be different formula, right?
The other formula you can I mean if you don't remember it, then
Yeah.
you need to just balance the uplift with the
Yeah.
gravity and the and the buoyant force, drag and the buoyant force. Okay. This I explained in, I think, the initial part of one of the weekly live sessions. You can
Yeah.
go
Yeah.
there and I mean get back to it, but this is very I mean if you forget this equation also, you can derive it within 1 or 2 minutes. This is done. What else is the most important question? Okay, and here this eta is basically cos theta 1 into square root of 1 minus tan theta 1 by tan phi square 1 minus. Okay, so from it you can find it out, where 30 degree is the I mean theta 1 is the bank slope angle, and phi is the repose angle of repose. What else? I'm just checking. Am I missing out on something very important or not? Okay, and then there may be one equation about the critical shear stress. So the shear stress tau star will be calculated as u star by square by g times g minus 1 times gs. So from it you can find it out. And what about the critical shear stress? Tau square star c is tau c by rho g minus 1 ds. So from it you can find out the critical shear stress also. Tau c is the critical yeah, tau c is the shear stress there. So this is done. What else? I think we are done. I think I don't want to discuss anything else. Yeah, yeah, we are done then. We are done. My recommendation is that just go through the assignment questions very seriously. Just go through the assignment questions very seriously. I mean, the solutions to the assignments will also be provided. I think Mr. Deka will be providing it on 22nd of September. Your exam is on 28th. Just solve the assignments questions. You will do very well after that. And you have to remember all the questions. I mean, the important equations. That is unfortunately one of the most important part of this course. Anything else?
The abutments covered follows the one or two if you can write that is sufficient. Maybe we
That I
can.
didn't note actually right in today's year.
Okay, and the other one is on that river equilibrium. So last like this week 7, week 8, something those.
So my recommendation is that just solve the assignment. I mean, you just I mean, what do we say? Solve the assignment questions very thoroughly, and then make a list of. I mean, like make one A4 sheet of all the important equations.
Formula.
Firstly, make the formulate the equations, and then you have to know that which expression is to be used where,
Okay.
and
Okay.
what do each expression means.
Yeah,
So
yeah.
that is what actually I did in my river engineering course. I took this course way back in 2017 January in IIT Guwahati. I was a master's student at IIT Guwahati at that time.
Okay, okay,
That
okay.
is what I did there.